This is Handout, the Atari XL podcast.
This is Antic, the Atari 8-Bit podcast. I'm Kay Savitz. Gregg Squires was a manager of hardware engineering at Atari from 1982 through 1984, working from their New York office. He was project manager for VAL, a cost-reduced version of the Atari 2600, and project manager for the Atari XL computer series. He was also co-designer of the 65816 microprocessor architecture. Gregg sent me a scan of an Atari 600XL product status meeting handout dated January 1983. It's an impressive 45 pages and paints a clear picture of the timeline, costs, and issues involved with creating that computer. You'll find a link to that in the show notes at ataripodcast.com. This interview took place on February 13th, 2019.
I was thinking I would quickly go way back to
Sure.
when I was in diapers and I took apart clocks and radios all the time. And as I got older, I stopped taking apart clocks and pretty much focused on radios. And then I got to the point where I could build them instead of take them apart. And I was just always really obsessed with radio. And I became a ham radio operator, which helped. Although when I was in elementary school, like when I was in third grade, I would build crystal radios. And I remember at one point I was attending a school outside Washington, D.C., right near the WTOP transmitters, 50,000 watts of AM. And I would build these little crystal radios that fit inside a ballpoint pen and then sell them to the kids in class so that they could listen to baseball games while they were in class on their little crystal earbuds. And that was a lot of fun. And then by the time I got into junior high school, I was able to do the ham radio thing and learn Morse code, which I really enjoy. Some people hate that. I really like Morse code. And then I spent a lot more time operating and building radios, which helped me get through high school, which was otherwise kind of boring. And so I got a first class FCC license, and I kind of had the equivalent of a double E degree by the time I graduated high school. Really. So my parents said, well, what do you want to study in college? And I made what I think was a really good choice. And that was I studied developmental psychology. I just wanted to do something completely different. And I think that really helped with my later career and might have been a contributing factor in how I wound up doing the work that I did at Atari. Because it's people skills that get you as far or further than technical skills. Now, I had a lot of technical skills, but the people skills, I think, might have been a differentiating factor in how the course of my life went. So when I was in high school, I did a science fair project, and it was and this was way back, this must have been the late 1960s. And I built a 4-channel analog multiplexer. Like, that was kind of state-of-the-art concept then, because there wasn't too much data communications going on at that time. And I had a little AM radio transmitter, and I fed 4 different tones into it, transmitted to a tube radio receiver, mind you, which received the signal, and then I had built some simple solid-state circuitry that sorted out the 4 different frequencies and used them to operate relays to turn on different lights and things that were part of the science fair project. Science fair judge came up to me and had me explain the project to him. He said, "Are you sure you built this yourself? Are you certain that your parents are not electronics engineers?" And they weren't. My mom was a geologist and my dad was a paleontologist, who later became a marine biologist and did some really interesting things. And they disqualified my science fair project. I went home and I was crushed. And my parents said, turn it into a teaching mode. And said, don't worry about it. And the next year, when it came time to do a science fair project, they said, don't do anything. we'll take care of everything. You go outside and play in the woods. So I went outside and played in the woods. And they built a science fiction. It was a science fiction. It was a science fiction science fair project that was entirely based on geology and paleontology. And they did the whole thing for me and coached me in how to present it to the judge. So I went to do the presentation of the science fair project and explained what it was and what it was meant to represent to the judge. The judge never asked me if my parents were geologists or paleontologists. And I won the science fair that year. And I think that taught me a lot of things, some of which one might be critical of. It certainly taught me about human nature. So, yeah, I went on to go to school and study what I studied in school, which was developmental psychology and some other things. But when I got out, I was lured by the money that I could make as an electronics engineer. And during this time, which was, like before computers, BC, as it were, Schottky, SSI chips were coming into existence, little building blocks, and lots of things were built out of them. I had sort of foreseen that. They say that musicians are blessed with precognition of their entire lives, maybe to help them through the life of being a musician. And I have been a musician for periods of my life. I've had that experience of precognition. Sort of saw the chips as little functional boxes before they even became available. And then when they became available, I was like, cool. And I started playing with them. And then I didn't quite see the microprocessor ahead of time quite like that. But I was in college, and the first microprocessors came out, the Intel 4004. And they started using them to build calculators and things like that. And at that time, computers were thought of as these big, giant things that AT&T had that screwed up your telephone bill. So people weren't really fond of computers at that point. And you can see that in the old science fiction today. So, but the 4004 came out, and I immediately started studying these things. I just thought it was really cool that you could have a computer on a chip, and foresaw that those would soon be in everything as they are today. So I kind of was doing my own thing. I was actually producing television commercials at WPTZ Channel 5 in Plattsburgh, North Pole, Burlington, Plattsburgh, New York. And a lot of these commercials would go into the Montreal area. And so for a while I made bilingual television ads, which were interesting because the idea wasn't to see how many words you could pack in 30 seconds. You had to communicate with images and music to get across to both language audiences in such a short period of time. That was an interesting challenge, was communicating to the bilingual audience. I did that until I ran out of money because I didn't make that much money doing that. And I retired back to Long Island, where I was raised. Found a job. I worked at Databit, produced telecommunications concentrators using the SSI chips that I alluded to earlier. And then as technology came along, this company started to use one of the first 8-bit processors was the Fairchild F8. And it wasn't designed so much to be a computer as to be a logic replacement, which is kind of brilliant in solving the problem of how do you sell these microprocessors in large quantities. So companies that were already producing complex electronics would use the F8 to replace parts. So instead of having maybe 15 or 20 or 50 or 100 chips, you could have the F8 and a couple other chips and replace all of that and write just a little bit of code to do it. And so this company that I was at started doing that. And that gave me the opportunity to get my hands dirty and start programming in hexadecimal and machine language, writing down hexadecimal codes and then punching them into an EEPROM programmer programming it that way. And that's how you did it back those early days of computing. Then I got a job with a guy who had developed the first 16-bit microprocessor, which was made by General Instrument out on Long Island. It was used in a few video games and also set-top boxes for cable TV, and who knows what else. And it emulated the mini computer of the day, the digital equipped PDP-11. And Jeff Stein was the architect. And having it simulate a well-known computer was great, because then you had a whole corpus of programmers ready to go that could program the chip. And that put them way ahead of Intel, because you had to learn how to program the Intel chips, the 8008 and up, and for that matter, the Fairchild F8, which rapidly faded into history. So I designed a development system for the CP1600 with Jeff Stein, and learned a whole lot more about programming and designing computers. And I had one or two other small jobs, and wound up with this company called Raycal Viconics, which had a storied history. Not all of it good. The Raycal part of it was a defense contractor for the Brits, and they had merged with the Milgo company, which was making early modems. I designed a bunch of stuff for them because I wanted to design computer systems, and that was where I really got started with that. I designed a credit card reader for American Express using a 6809 processor and some early AI techniques that I developed to handle reading the card successfully in one swipe instead of having to reswipe it, which is what people had to do frequently back in those days. Swipe it 2 or 3 times to get a good read. And I developed the first UPC barcode label. Those are the inventory and price tags that are on everything in the supermarket. And it was a very, very difficult barcode to read. The people that designed it were bankers, and they didn't really know about barcodes. So it was a hellish barcode to read. And I developed this barcode reader. It was the first one that was actually sold. It used an HP scanning wand. So you'd have to hold this wand like a pen and scan the barcode. And people didn't like doing that. So very rapidly, they preferred that cost about $3,000 to buy, the one that I developed. And IBM developed a laser scanner version, which cost $85,000. But people disliked the pen so much that the IBM laser scanner took over that market. And so they didn't really sell that many of the ones that I designed. But they did sell it into like non-consumer channels. And then I went on to design a full-blown computer system that was used in managing fire systems and security systems for high-rise buildings in New York City. People that live in New York will know that New York City has its own requirements for those that building owners must comply with. And so there's this whole marketplace of selling this equipment that meets the requirements for New York City building codes. And so I designed computers that sold into that market. And that's when I met one of my associates there, who's an electronics engineer, also Robert Card, the printed circuit board designer, Stephen Ray. And we worked together on building those computers and had a lot of fun. We were all interested in it. Developed a technique called critical damping, which allowed building electronics equipment without those shields, those metal shields that you see on printed circuit boards that help them to pass FCC certification so that they don't radiate unwanted radio signals. And that allowed for producing very inexpensive electronics. And we also, I developed a floppy disk controller, which used, think of how to describe this, it used basically memory as a state computer. These kinds of devices were rapidly becoming commonly used and called data rates. but I used in the floppy disk controller, it was just a memory chip that I used. I basically programmed it to be a phase lock loop when it was clocked by the circuitry. Convert the electrical signals from the read head on the floppy disk drive into digital signals, and it would do it without any analog components, which meant that you could build these controllers and they'd be very reliable. They'd come off the production line and they'd have a high probability of working and a very low failure rate. So, and that was very important to reducing costs. These were techniques that we took to Atari. And from that company, it was actually Bob Card who found out about the job at Atari. Went and talked to my future boss there, Steve Mayer, and told him about what we were doing at this company. And then he came back and talked to me and said, "Hey, I think we should leave and go do this." And I said, "Cool, I'll go talk to this guy." And I went and talked to Steve Mayer, and it did seem to be the thing to do. So I got hired as a manager of hardware engineering for Steve's research and development lab in New York City for Atari, which had just been purchased by Warner Communications, and took Bob and Steve Ray with me to Atari. And so they became key members of my team there. And we took that technology, and there were two other technologies. Well, yeah, there were two other technologies that I took with me there. One of them was besides the RF shielding technology or critical damping technology, I also introduced project management, which came about of necessity. So we were working at Atari in Atari R&D, and Steve is.
What they put you to work doing, first day? What they?
Well, that was the interesting thing. We didn't really know. I mean, Steve had created the original 2600, and he was involved in developing the CTIA, the television adapter chip, at Grass Valley, which was a sort of an R&D engineering kind of thing that Atari had purchased. And those guys from Grass Valley developed all the early silicon, custom silicon for devices like the 2600. That included the CTIA chip, which was used in the early the 2600. So he was elevated as a result of that to starting this R&D lab in New York City. He wanted to leave the West Coast and go to New York. This was how he did it. I think his wife wanted it more than he did, but Nancy, his wife Nancy, she would occasionally try and insert herself into the business there, which didn't really work out that well. I don't think he really knew what we were going to do. I mean, it was research and development, right? Blue sky, green field, whatever you want to call it. And nobody really knew, so we just sort of set up shop and got offices and furniture and test equipment and a lab. I was given a budget for setting up a lab, and so I had a lot of fun setting up a lab and hired a technician to do technician things. A bunch of other interesting characters were hired to work there. Stephen Radosh was hired to be the software manager. Atari imagined itself to be a computer company, which was very appealing to me. And so I was the manager of hardware engineering. Steve Radosh was the manager of software engineering. And they hired some other people, like this guy, John Zeno, who was really kind of a genius. He invented all kinds of things. The problem was that his inventions weren't terribly practical. You would see an invention and go, "Wow, that's really cool. What do we do with it?" I don't know. Like, he didn't know. Nobody knew. And,
do you have an example?
Sure. He came up with a really interesting, in that how simple it was, device that was a pointer device to the screen. You could have a television screen, and in those days of the CRT screens, it's a bunch of lines being painted on the screen by an electron ray, which is hitting phosphorus to make it light up. And so, but there are actually lines, and the scan is repeated over and over again in real time. So you have a connection to time with location on the screen. And he built an incredibly simple thing. I think he used like 5 parts, 5 electronic components that allowed him to point at the screen and get a cursor that would appear on the screen that you could move around. We never,
So the light pen.
yeah, and we never figured out a way, though, to connect that to anything to make it useful. But it was mind-boggling how simple the device was. And he developed all kinds of other cool stuff that I didn't describe. And it was all that kind of stuff where you go, wow, that's amazing. And wow, how did you get to do it with so few parts? Which was, Steve Mayer was all about building low-cost things, which is how Atari became so profitable. So the 2600 was cheap to build for its time. And so he was all about making that a hallmark of the Atari products so that it could stay successful in the consumer arena. John certainly fit into that model, but like I said, we just couldn't monetize it. And we would have group meetings where everybody that was there would get together in a room, and Steve would get, who you've interviewed before, Steve Mayer, would get up in front of a whiteboard and sort of, you'd say, okay, Steve, what's the meeting about? And Steve stuttered pretty badly at that time. I've sort of inherited the stuttering. I'm not really sure for what reason. So you hear me stuttering while I'm talking here, but it's nowhere near as bad as Stephen did. At the time, I didn't stutter at all. So it's just something that's happened along the way to me. But he would be stuttering and sputtering and waving his hands around in the air and trying to express something. We didn't know what it was. And in retrospect, he may not have known what it was either. But we would all start trying to please him, trying to guess what it was that he's trying to talk about. And he would lead this process with the waving and the stuttering and trying to explain, well, it's the thing and the thing is, and he would peter out, and it was always impossible to figure out what he was talking about. But we'd eventually come up with great ideas through this process. And then he would sort of steer them into the land of practicality. So that was his genius. His genius with me was that while this was going on the West Coast, Atari was becoming bigger and bigger and bigger. It had grown to 57 buildings, tens of thousands of employees, and they were keeping themselves very busy, but they weren't developing new products to replace the 2600 and the early computers, 400, 800. And the executives like Ray Kassar and Michael Boone were starting to get very concerned. And the president, there were 4 presidents of Warner Communications, and one of them was in charge of Atari, and that was Manny Gerard. These guys were all becoming very concerned that there were no new products coming in to fill the pipeline and keep Atari on top of their game and grow the company, which was clearly what Warner Communications wanted. And they became more and more upset as time went on. And we would have these meetings. They would hold meetings, partly because we were located in New York City at 42nd and 2nd, across from the Daily News Building, partly because they were hoping that Steve Mayer would have answers for this. So one day they're having this discussion in this meeting, and I'm present. Steve Radash was present. A couple other people from the group were present, and one of them turned to, I don't know if it was Manny Gerard or Ray Kassar, it was one of them, turned to Steve Mayer and said, what are we going to do to fill the pipeline with new product? How are we going to do that? And Steve looked up and sort of scanned the room and pointed at me. And he said, Gregg will do that. And of course, I was in a state of shock. Like, okay, how am I going to do that? I mean, I was a young kid. I was game. I was like, that sounds like something I'd like to do, you know. You know, it wasn't all my idea, but rapidly what shaped up was that the first thing I was going to do was come up with a video game that was a replacement for the 2600. That's how the Val video game came into being as an idea, as a product. We started developing. Steve was a great mentor for me on this because he steered me along, but he let me do the work and make most of the choices. And he was just there to correct me if he thought I was going the wrong way. He was there to make sure that the design was cheap and that it was manufacturable in high volume. And other than that, I was pretty much turned loose on this. And I was a New York kid, you know, I didn't know much about the West Coast. I had gone out and visited the West Coast and really didn't feel like I fit in with the Atari scene there. And these guys, meaning the C-level executives, seemed to think that that was a good thing. They felt that getting this started outside of that environment would ensure that that this would get done and get done quickly.
My understanding was the Val was a cost-reduced version of the Atari VCS. Was it to add more features as well, or was it just strictly like a prettier package and make it for cheaper?
An improved, cheaper to manufacture package that was compatible with all the game cartridges that worked with 2600.
Okay.
And the Val would have the CTIA chip in it, so that the video and the same microprocessor, the 6502. So it was essentially a next generation 2600. So you're correct about the design goals for it. The way that I went about it was, first of all, I was overwhelmed with the idea that I had a $22 million budget. I had to produce this thing in a ridiculously short amount of time, that I was going to do it with a very limited number of people. So I took off a couple of weeks and learned project management at NYU, which was something that was not being used. It was being used to build buildings, but it was not being used to build computers at that point. And I learned the critical path method there, which if you use Microsoft Project, sort of a watered down version of CPM today. I learned how to use that and decided to design the project for Val and later the XL computer series using the CPM method. Atari didn't want to spring for the software, which cost $35,000 and needed a mini computer to run on. So I had to do it by hand. So instead, some space had opened up on the floor beneath the floor where the R&D lab was. They got it for cheap and stuck me down there so that I would have some peace and quiet and solitude. And then I took my secretary, Reese Rosenberg, R-A-S-E, like spelled like Rise, Reese Rosenberg. I've been in contact with her a few times in the not too distant past, and then lost track of her again. But I know that she's still around, last I knew. But she was very helpful as a secretary. Back in those days, we had secretaries, help keep things organized. And she and I moved down to this floor, and I started covering the walls with with CPM project management charts and figuring out the schedule and collapsing it down to the shortest possible schedule to get that thing kicked out the door. The reason that it cost $22 million in part was that we needed to get it done so quickly. Also, we were being asked, or I was being asked to, I was afraid to accept personal responsibility for this. Some of those say we. But I was being asked to do this pretty much separately from Atari resources. This turned out later to be a disastrous decision. But Atari's manufacturing capacity was filled up with 2600, Atari 400, 800. So I had to wing it and use outside resources. So I made a couple of decisions that in retrospect I think were really good. And the first one was to have the package designed by Henry Dreyfuss Associates, a professional industrial design firm the 2600 was designed by some of the guys out in Silicon Valley at Atari headquarters, Borges Avenue there. It was a pretty ugly box, right? The design of it was part of the reason for the cost being higher than it might otherwise have been. I believe the cost of manufacturing the 2600 at the time that I was there was somewhere around $24. And I think it's sold discounted for as little as $75 or more if we were lucky. And so the profit margin could have been better for a consumer product. They want it to be like 3 or 4 times the cost, if possible. Steve had done some of the thinking on this ahead of time about how we would accomplish it. So I wasn't starting from scratch there. But I did introduce the idea of, hey, let's have this thing professionally designed so that it looks really good. And I think
it looks really good. It's
such
I mean,
they put all kinds of crazy detailing into it. They knew a lot about plastic molding because they designed the touch-tone telephone for AT&T. They designed the Polaroid SX70 camera, which millions of people were using to shoot instant photos, and all kinds of things like that. That devices that people held in their hands and used and hung around the home, and they knew that housewives, for example, hated the 2600 because it had these joysticks and the cables, and it was hard to put away and tidy up. This thing was designed so that the joysticks were built in. You could plug. They had jacks in the back, so that you could. And you might want to look at the picture of this while I'm talking. They had jacks in the back where you could plug in the old style Atari joysticks and use them because they were heavier duty, and you might prefer holding that in your hand with a wire. But it wasn't necessary, and the idea was that the basic unit would be this beautiful thing to look at. You put it on the kitchen table, and it wouldn't look horrible, and the wife wouldn't go crazy. And if she wanted to put it away, she could just stick it in the kitchen drawer and close the door. Maybe with a few joysticks in there and cartridges, whatever. So, and the power brick and the connection to the television. So these were all things that created clutter that housewives kind of tend to detest. Even to this day, my current girlfriend can't stand having the wires around. She says, I'm full of dingly dangly. That's how she expresses it. But it seems to be a universal thing. So they did a lot of human factors, analysis, and engineering. When you look at this thing, every single line in it is not straight. There are no straight lines in this because you can't mold plastic into a straight line. You can try, but when it comes out of the mold and as the plastic cools, it will turn into something that's not a straight line. And Dreyfus had a lot of experience with that. They knew how to design plastic so that when it came out of the mold, it would come out the right way. Instead of trying to design things as straight lines, and then you mold the plastic and the straight lines wouldn't be there, and it just would look not right. So that's part of why this is pleasing to the eye. Everything in it has a radius, as they would explain. Even the top surface has a 300 some odd radius, 300 some odd inch radius. All the sides and corners. And that also meant it had no sharp corners. They wanted to get rid of that so that people wouldn't bump into them and get hurt or feel it as a sharp pain or anything. Even the joysticks, if you look at them, they're designed to be easy to the touch with no sharp edges, very smooth. Designed also so that you couldn't put too much leverage on them to break them. They're relatively short. So a whole bunch of engineering considerations went into that. And then we put a lot of other innovations into it, like the RF critical damping technique that I introduced at Atari that got rid of those metal cans on the printed circuit boards and made it cheaper to make the printed circuit board and made it possible to pass the FCC requirements for radiation without having to have all that extra stuff. It made it cheaper to make. So we eventually reduced the bill of materials from about $24 to $12. And that's one of the things that I hope that listeners to this podcast will get out of this, is some insight into how things are built for mass manufacturing and for lower costs. Henry Ford started the whole process out with the Model T Ford, which he knew that every American should have a car, and that it was necessary to make every design decision with cost in mind, because if you're going to make 10 million of something, a difference of a penny adds up to a lot of money. And the same is true of cars today. A lot of engineering efforts put into holding the cost in. This is what we did with everything that was manufactured at Atari. And one of the things that separated Atari out from other companies that were building things at the time, like Apple with its Apple II computer, was that used all standard parts, and it made it very easy to pirate. We reduced the parts count in this device and the XL home computers by using a lot of custom custom chips that were extremely difficult. At the time, they were impossible to reverse engineer. And so the Atari stuff was not pirated like the Apple stuff. There were no 2600 pirates because the CTIA that Steve Mayer had designed was custom silicon, and I don't think anybody ever did it to this day.
Yeah, that's fascinating, because there were pirate Apple IIs and TRS-80s in other countries. Yeah, that's really not something that, as far as I'm aware, happened with the Atari. And you're saying it's because the custom ICs were hard to
right. And that was one of
copy.
the thrilling parts about designing these two products at Atari, was doing designing the custom semiconductors. Designing chips was a lot of fun for somebody like me with my technical interests and engineering interests. Also, Robert Card, the engineer that I brought from Raycal Victronics, was very interested in that too, and really relished and enjoyed the time that spent designing those custom chips. The Atari had a Gatorade chip in it, which I designed, and Bob validated, checked. Not too many people that could check things like that back then. The simulation software was pretty crude. So Bob was the checker of my work. And so the Atari, the VAL video game had the low costed 2600, if you want to call it, had this Gatorade chip in it to reduce the chip count. I developed that to be cheap. It was definitely cost saving. And so we eventually got VAL into pre-production. That was when we discovered some of the bad decisions that had been made, like to develop it in isolation from the guys out on the West Coast. They hated this device. They felt it was not invented by them, not invented here syndrome. They didn't want to have anything to do with it. They wanted to kill it. They were very miffed that they felt that they hadn't had the chance to design this, but they were wrong. They did it. They had 2 years to design something like this, and they didn't do it. And that's why I wanted to do it. Huh. There were, as it slid into the production process at Atari Consumer, which was where all the games came out of. It was headed up by Mike Moon at the time. Mike Moon was a crazy character. He was one of these guys where, you know, if a normal person like me puts on a suit and a shirt and a tie, by the end of the day, it's like all rumpled and, you know, not crisp and tidy. But Mike Moon was one of these guys where he could go on an airplane flight from the West Coast to the East Coast and sleep in the plane and arrive at the other end and adjust his shirt and his suit, and it would look like it was freshly pressed. And his haircut was no hair out of place. He looked like a Ken doll. That was the joke. So he was like a Ken doll. He always looked perfect. And but he was great in meetings. He always looked the most crisp and the most tidy of anyone there. It was a challenge to come anywhere close to his Ken doll appearance. So as this product found its way into his organization, they started systematically trying to figure out ways to kill it, and they eventually did. And one of the ways was to cast plastic that was used in focus groups where people were testing it and they were getting some idea of how people liked it so they would know how to market it or maybe changes to make, which they were very interested in doing so that they could stamp it with their hands, so to speak. I could say put that another way, but I don't want to use that language here. They had it cast in blue plastic. The buttons were cast in yellow plastic. Then they had people test it. And somebody made the comment that the colors made it look like a bruised banana. And they took that phrase and used it as a way to kill the product, which was an interesting perversion of the whole idea of industrial design, because Dreyfus had specified the color. This was to be casted. If you look at the black and white picture of it, which is circulating around the net, you might not notice it, but or you wouldn't notice that it was designed to be the warm brown color. And even the label on top of it with the Atari logo was a warm brown with Atari and the Atari logo device in gold. And the buttons were in sort of a burnt orange kind of color. So that the very fashionable, carefully chosen colors that were designed to blend in with the home screen and look stylish. And so changing those colors was immediately asking for trouble, but they did it intentionally. So eventually it unraveled and did not become a mass-produced product. But a lot of the technology that we put into it became you mentioned it earlier, what was it, the 5700?
Well, there was eventually there was a VCS Junior, and then there was the 5200, which was really an Atari 400 in a bigger package. So I'm not sure.
Yeah, it became that, and some of the custom circuitry wound up in that. But that was essentially developed on the West Coast, and that was the whole idea. Was they really didn't like the idea of these guys from New York helicoptering in it with a new product that they didn't build.
That just seems so ridiculous. I mean, it was the same company, just a different office, and I don't know, it just seems ridiculous to me. But I wasn't there.
Well, in the years since, I've worked for many companies. And while I was still working in New York, I worked in New York for a couple of decades after that. I wound up working for just about every Fortune 100 company that existed in New York, which is most of them. And I found that those kinds of political shenanigans are pretty much universal in large companies. And I learned that was a very expensive lesson that I learned at Atari, and I didn't make that mistake afterwards in all the work that I did at other companies. That was a very valuable lesson, but it was a very expensive lesson. It wasn't just my mistake. Steve Mayer was all gung-ho about this, and C-level executives were gung-ho about it. We were all guilty of making that mistake. But when it came to doing the XL home computers, we learned from that mistake and involved as many of the people in the home computer division, and it was a separate division so that they weren't spoiled by the experience of the Valve video game, the VCS 2000. They weren't tainted by that experience. And so I spent a lot of time shuttling back and forth between New York and the West Coast to involve them as much as possible in the design of the XL series.
All right, so let's move into that. So how did you get put onto that job of doing the XL series? And so I understand you did the 1200 XL as well as the 600 and 800 XL.
Well, it started out as the next generation 400, 800. Mm-hmm. And what happened was that John Constantine was brought in to become the president of the home computer division. And he had come from the world of consumer packaging. He decided that there were a couple of things that he wanted. Now, I sent you pictures that hopefully will make it into reality somewhere along the line of early versions of the Atari 600 XL.
Yeah.
Because that's all I have left is pieces of the 600 XL. At one time, I had a 1400 or 1450, and that burned up in a house fire that I was in. But John's idea was that every product needed to be in the small economy size, the regular size, the large size, and the extra large size. And that was how it wound up that there was a 600, an 800, 1200, no, I think it was 612, 14, and 1450, however that worked out.
Right.
And but they were all based on the same design, same circuitry, the same chips. It was just the size of the cabinet was different, and certain bells and whistles were added or subtracted to have an excuse for charging more or less, depending on whether it was bigger or smaller. And he was constantly likening this to selling cereal, which at the time was being sold the same way. You have the small economy size cornflakes and normal size and large economy size. Those are being sold. So he was intent on that. He also, in the images that I took today, and I'll try to get more, the early version, the 600, the plastic design was very different. It had those fluted vents on top, and it was all dark colored, and it had regular computer keys along the side as function keys. It looked much more like it was a Henry Dreyfuss inspired design. The guy at the home computer division that designed that version had taken a look at what we'd done with the VAL computer and learned a lot from studying that. And so it was very inspired by the VAL design. So it was a little, and then they said it was, John Constantine said it's too dark. So the white plastic was introduced. He didn't like this was all, executives dictating stuff, which is micromanaging, which is terrible. But that's what he did. And he didn't like the fluted design on top, so it became this sort of weird ventilation hole arrangement that you see in the final product. And he wanted there to be silver somewhere visible. And so the function buttons along the right became silver keys. And those were his contributions to, as a design expert, to the product. And it's not that he was a monster or a bad guy. I had many things with the guy. This was coming from his heart, if we may say it that way. He really felt that it needed this way, and that he had the consumer expertise, and we were a bunch of engineers that didn't know what we were doing, that we needed to do these things. So that's how the silver function buttons got that way, and that's how the white plastic became that way. We did keep some of the good ideas from Henry Dreyfuss, like the use of cycloac plastic. The feel of those devices was very nice and kind of solid and tactile because cycloac plastic was used. Nowadays, everything is polypropylene, which has a very brittle feel, and you tap on it and it has a sort of cheap sound. And if you smash it, it breaks into pieces. Cycloac was a much more sturdy, flexible plastic. It was the same plastic that the desk phones that AT&T made, that those were made out of. And those could take a lot of wear and tear, and you can smash them and break them, and they wouldn't break into little pieces. They might crack, but you couldn't break them into pieces like you can with the modern polypropylene. The drawback being that the cycloac costs a little bit more. But the VAL product and XL series home computers were designed to be cast out of cycloac. So that's how it got to be that way. So I have before and after pictures of those design changes because the project was already well along when John Constantine came to the home computer division. The document that I sent to you yesterday, which is
Mm-hmm.
to pass along to listeners, was a handout to a high-level presentation that was done on the 600. So this was presented to the likes of Ray Kassar and Manny Gerard.
Mm-hmm. This is the Atari 800 XL product status meeting handout dated January 7th, 1983.
Right. And the first part of it is kind of cool because it's typewritten by an early selectric typewriter that Lisa Rosenberg typed out. And it wrote these bullets. Mayer contributed to them. So there's a bunch of bullets, what you would call slides for the first few pages. So it's kind of, the overview, low-cost computer major objectives, produce as many units in 1980 as possible, 10 plants, 11,000. 200,000 were going to be produced domestically in Monterey at a facility there. And the initial production was going to be 85,000 units. Eventually, it's my understanding, they made tens of millions of these and allegedly in Hong Kong, but we'll get to that later.
Yeah.
Aggressive cost reduction. Steve Mayer getting his fingerprints on this, but it's the whole idea of the thing was to reduce the costs and keep Atari profitable. And those early Atari 400s and 800s were very expensive to build. They had a lot of those mechanical shields that I was talking about that I engineered out of the process. And here it shows you that it's $127.65 to build the A400, and then the 800 cost even more than that. So that made them pretty expensive. They had to sell them at a higher price than they really wanted to. And they were competing with the Commodore 64 and the Apple computers. And so price competition was very important. I remember Steve Mayer coming into my office one day with the Commodore had an even cheaper version of the Commodore 64. What was it called? The VIC-20 or something like that?
Yeah, that's right.
And he came into my office with the VIC-20. And he said, "Oh, look at what Commodore has come out with, this really cheap computer." And I said, "Well, how much are they selling it for?" And we talked about that. And we started hypothesizing how much it costs to build it. And we wound up taking the whole thing apart on the top of my desk and coming up with a bill of materials and starting to analyze it. So the competitive pressures were very, very high. So you can see here, we were trying to almost half the cost. The 1984 cost objective for the 600 being $65. And I think we met that goal and maybe even better. Major objectives continued. Offshore manufacturing. That made me spend a lot of time in Asia, which was very interesting for me. Because eventually this thing was manufactured in Hong Kong, allegedly. But actually it was manufactured in China. But Americans weren't allowed to go to China. China was all sealed off at that time, if you review your history. At one point, I was smuggled into China to see the actual manufacturing facility, which was in Shenzhen. It was one of the early factory cities China built so many of. And it was really interesting because it was beautiful. It was clean. The employees lived inside the factory, but their living conditions were pretty good. They would eat in this company cafeteria that was awesome. And the food in it, especially if you like Chinese food, the food in it was really, really good. I had all this awesome fresh vegetables. Everything was just really good, healthy food. Just a really strange concept, though, because people lived in the factory where they worked.
Wow. But the factory was in China, even though the computers were allegedly made in Hong Kong. Was this true for the life of the XL products?
Pretty much, as far as I know.
Wow.
And there were a lot of products, not just Atari, that were being made that way. So that companies would maintain, little offices in Hong Kong, call themselves factories, and take orders for produce large quantities of things, and they would just funnel this work into China, smuggle the stuff back, and they would wind up as boxes stacked in these small little offices and getting shipped out. And you would go to them, to say they would, trying to sell me oh, we can build this for you. And I would see all the boxes in an office with one or two people in it and say, well, this is great, but where is this actually being made? And they would start out with, well, you don't really want to know, or that's a secret, we can't tell you. And I was saying, well, if you want the business, you're going to have to show me that you can actually manufacture this. And I had a guy, I forget his name, in the Atari purchasing department who was with me to also help with making sure that we were keeping these guys honest. And so at one point they smuggled us into China, and there was some gunplay involved with a rival firm, which was terrifying, racing through the streets of Hong Kong in a Porsche that was being driven by one of the companies that was trying to entertain us. And then one of their competition was chasing after us in some other sports car, firing shots. It was like, whoa, I didn't sign up for this. But we did survive the trip into China and eventually got smuggled out. And but we saw the factory and we were convinced that they could do the work.
Holy
and
cow.
So we went ahead with the deal.
Did Atari's management have any, did they know about this? Was there tacit approval,
No.
or they were completely ignorant?
No, we saw nothing.
Huh. Wow.
But we wanted this to be a successful product.
Uh-huh.
And we weren't really changing the way things that were done. I mean, we just learned how it was being done. That was how we looked at it.
Right.
By we, I mean me and the other purchasing guy that was with it. Yeah, I mean, we attested that they could actually build these in quantity on time, and they did. Then there's some other pages here and talk about the critical path items on schedule, that scheduling schematic is complete at this time. And then it starts talking about some of the chips. And then accomplishments, keyboard spec goes. And we've gotten a lot of work done in a very short period of time before this meeting took place. And there was even a preliminary bill of materials that showed how we were getting it down to, at that point, $71.95. But eventually we got it even lower than that.
So I want to stop for a minute and talk about the chips. Atari people all know Antic and GTIA and Porky, but this document makes several references to a chip called Porky. Was this a different version of the Porky chip, or what's going on with that name?
Yeah, it was a redesign of it to get more into the chip and to low cost that chip. Bob Card did most of Porky. I did some of the initial design. And sort of got it going, and then turned it over to Bob because I was managing, wearing a lot of hats. I project, so I was the project manager. I was designing a lot of the circuitry. I was the product designer, designing as much of it as I could, and pushing it along that way, and enjoying that part of it. And sort of being his hands-on as I possibly could. And that kept me really, really busy. So Bob went off and did that chip, and he deserves a lot of credit for that because he did it on his own, pretty much single-handed. All of the chip design that I did, I had Bob available to check me. Boy, that was helpful. So we get past the slides, and then there's this long document that I wrote, which was basically the product specification. And Atari prided itself on computer company. This is written as a sort of a computer document. It's written as if you already are familiar with the previous products, and you're familiar with them on a deep technical level. If you look on page 3, this is a question that you asked earlier, Kevin, about the Atari 600 in comparison with the 1200. So we were already going to have those two models, and I'm constantly adding the other two.
Well, the 1200 was released 6 months before the 600 and 800 XL.
That was a business decision.
Okay.
Of which one they wanted to introduce first. We were busily designing them up. I personally liked the 600 the most because I wanted to put computers into the hands of consumers as cheaply as possible, and so that as many people could have computers as possible. I wasn't really thinking so much about competition with Apple or with Commodore, I was just thinking about getting computers into the hands of everyday people and having them learn the technology and put them to use in their lives, because I thought that was a really, really good thing. You'll see a lot of mentions of Liz, which was one of the project names, as well as Crazy 8. Liz was my wife at the time. And the Val computer. Val was the girlfriend of Joel Moskowitz, who was the mechanical engineer on my team. And Joel was an interesting character, and he insisted that we name that thing after his wife. I said, fine, for his girlfriend. And I said, fine, but I get the next one. So that's how the XL became Liz.
So Liz was your wife at the time, right?
Yeah. And Joel went on. Where is he now? Where is Joel now? Because Joel's actually a cool guy. He went on, after he left Atari, he wrote a book called The Clock. In the book was a pattern. If you cut out the pieces of paper and put them together the way he described, it created a moving, working clock, like a grandfather clock, out of paper. It was just the most amazing thing you could ever imagine.
Oh, yeah, here's the
and
book.
It sold today. What? Edmund Scientific published that book.
Huh.
The clock book by, or the paper clock book, I'm not sure, one or the other, by Joel Moskowitz.
Yeah, the Working Clock Timer by Joel Moskowitz. I have the link here. How did Liz feel about having a computer named after her? Did she care?
Actually, she did. She was becoming ill, although we really didn't know that it was terminally ill at the time. And so she was just dealing with her own health issues and dealing with the fact that I was away a lot of the time. That was difficult for her. So I commuted to the West Coast during a lot of this. And I had a commutation pattern where I would work Monday, Tuesday, and Wednesday morning in New York at the R&D lab with my guys. And then at lunch on Wednesday, I would go on the East Side helicopter shuttle to the airport. There's a helipad in New York City on 42nd Street on the east side and First Avenue or somewhere around there. And then over on the west side by the Hudson River. From both of those heliports, you can go to any of the airports, like shuttle services. So I would, walk the one block over to get on the helicopter, fly out to JFK, jump onto a 747 jumbo jet, fly out to San Francisco. The San Jose airport was not big enough to handle nonstops at that time. And so I had to fly into San Francisco, rent a car, drive down to Sunnyvale, and check into the Sunnyvale Sheraton, where I had a permanent room there. Check in and then start attending meetings Wednesday afternoon. And then usually Wednesday night to decompress, I'd hang out with the engineers and other guys, managers that were working on the project on the West Coast. And we'd hang out and drink and have dinner. And then I'd call it a night and recuperate. And then I'd have Thursday and Friday as full days in Sunnyvale. And Bob Card accompanied me maybe 50 to 75% of the time. So he was present with me most of that time. Steve Ray, the PCB guy, he stayed back in New York. Friday night, we would we'd be scheduled to take the shuttle, the red eye, as it's called, back to New York, because it leaves around 9, 10, 11 o'clock at night, and it gets in to New York in the early hours of Saturday. For me, I would get home as quickly as possible in time to jump into bed and have Saturday morning at home with my wife, so that I had at least some kind of a normal existence with her on Saturdays and Sundays for the weekends. She had a part-time job during the week that helped keep her occupied, and that was how she was able to cope with my extended absences from working on these projects and frequent travel to the Far East. Bob Card, on the other hand, didn't have such a great relationship going on in his life. So what he would do was sell his ticket. Atari would issue him the ticket to come back to New York. And there's always people, to this day, it's my understanding, fighting for seats on those red eyes because they've just got to get back to New York. If you're a New Yorker and you're in California, you want to get back to New York really bad at some point. It's just a New York thing. And so there's always people there fighting for seats on those planes. Bob would auction his ticket and make enough money by selling the ticket to have a great weekend in San Francisco. It would pay for his hotel room. He could go out and eat like a king and do whatever there was that he did on the weekend, R&R, and then he would either stay there for the next week or fly back to New York. He wasn't quite on the same schedule. So I was doing that every week. He was less so. That made life for me very interesting. So I had my secretary in New York, and I had a half-time secretary in Sunnyvale, who the other half of the time she was working for one of the Atari vice presidents, who was a guy from Intel. I can't think of his name. He's one of the founders of Intel. I shared a secretary with him, and she would communicate with my secretary in New York, Reese Rosenberg, and they would have this constant dialogue going that kept me on track because I started to feel like I was living two separate lives, and it was making me almost schizophrenic at times. So those two secretaries helped keep me together during the course of these projects. So I'm going through, that's the dot matrix part of the presentation, and then that's followed by a block diagram called the Atari 600 computer system block diagram, which I actually remember drawing this diagram. And that is definitely a diagram that I drew. It looks like a diagram. and it was made by hand, you know, with a ruler and a pen, and then the text was typed in with a selected typeface. And then there's another page with the parallel bus pinout, which is a whole interesting story because there was a lot of contention as to whether or not the XL series would have an exposed parallel bus. And me and my team in New York, we were fighting for it because it was an open system kind of thing. And Steve Mayer knew intuitively, as did we, that having an ecosystem of third-party vendors would benefit the product, the lifespan of the product, and the number of units sold. And that trying to keep it proprietary the way Apple does it to this day was not a good thing. But the guys in Sunnyvale didn't agree with it. The device had the serial bus that the disk drives and the printer connected to.
Right, the SIO proprietary thing. Yeah. Correct.
And they didn't like this at all. So we would send out diagrams, both schematics and diagrams of the case that showed the bus and its presence there. We would get back diagrams with it removed. And you can even see in the picture the click of first plastic for the early version of the device where they took it away, and there's no hole in the back for it. And then eventually they compromised by saying, okay, you can have a hole for the bus to stick out, but it has to have a cap that goes over it, so that when you put the cap on it, you can't see it. And that was kind of the compromise that we eventually.
The little plastic cover that can cover the bus. Great. Oh, good. Seems like a decent compromise.
Then there's a lot of blood was spilled over there. And then in this document, we've got the pages where you can see the actual cost breakout, every single part. This is key to low costing and keeping an eye on the numbers. And the top level executives who were not engineers paid a lot of attention to these numbers of how much each part costs. And they kept their eye on that like hawks. That was their thing. It was how we kept the price down. It was by constantly keeping an eye on the cost of every single part and reducing the parts count where possible. And then the final section of this document is the project management section, which has got my name and phone number on it, because I got there's a lot of feedback about this. I didn't just create this schedule in a vacuum. I had to collaborate with all the people that were working on the project, which in the end, there were hundreds of people that worked on this project, somewhere between 200 and 300 people that I knew of, and maybe indirectly more. This is the product of constantly reaching out to people and saying, how long is it going to take you to do this task? And getting feedback and then fitting that into the project and then revising this every week. There would be a new version of this so that we could track how we were doing. And so there's a page with the silicon schedule, which shows you the basic chips that were in the device. So it describes the Fred chip, which I designed. That was a gate array. It was designed at LSI Logic in Sunnyvale. Porky, the version of Porky that had added circuitry that Bob Card did, that was a full custom chip done at LSI Logic. And then Rufus, which was I believe that was the operating system and the system ROM, which was developed by Paul, can't think of his last name, and his software development crew at the Home Computer Division at Sunnyvale. They developed all the software that was in this part. And then Rose, the 8K chip that contained the Atari Basic in ROM, so you didn't need to have a cartridge for the Atari Basic, it was built in. And PIA, that's an interface chip that provides the electrical connections to all the innards of the computer system to make the chip. And then we have we simulated that initially with an electron, the erasable and programmable ROM, which is called an EEPROM. We eliminated one of the E's there. It's actually EEPROM, not an EEPROM.
Mm-hmm.
So we say EEPROM, but it actually has two E's. That allowed us to make prototypes and iterate through the early versions of it, get it through FCC certification so that it could be manufactured and so on. And underwriters, laboratories, and all that. So all these certification have to pass the product design before you can go on to manufacture. And there's a second page here that describes some of the other Fred chip related stuff and the FCC certification. And then you see build and debug processes that are broken out. And anybody that wants to know how a computer is designed and how that design progresses in manufacturing can see that laid out here for the first time. Because, when the Apple II was designed, for example, there was no such project management that was done. To my knowledge, the Commodore 64 and the VIC-20 were built without a project plan like this. So this really spells out the process in a way that wasn't being routinely done back then. Of course, today, if you design a project, the project planning is done very rigorously from the start, and there's no exceptions and no variation.
Sure. Talk to me about rearranging the circuitry in order to do less RFI and with less cages to keep in the radio frequency stuff.
Well, at that time, the state of the art for getting electronic circuits to pass FCC certification was that you would identify parts of the circuit that were radiating signal, and then you'd put a shield over it, just basically a little metal tin can that had little tabs that would insert into the printed circuit board and be soldered on there so it was grounded to act as a shield. And most people are familiar with the concept of a shield, metal shield, keeping out radio signals. I mean, I think just about everybody knows that happens. But what happened was that it was pretty obvious, although initially we didn't know why, that those shields were not perfect at keeping the signals in or shielding. I developed with Stephen Ray, the circuit board designer, this concept of the critical damping method. The original idea actually came from Intel, but it was a different variant. They were using it for different reasons as a way of maintaining the wave shape of high-frequency signals coming out of their chips because everything was being made to go faster and faster and faster, and it started to exceed a lot of the techniques that were in use at the time. So that was why Intel came up with this idea, and we took that idea and developed it further to turn it into a way of eliminating these shields, these cans as they were called, from the circuit board, replacing them with critical, as we call it, design of the printed circuit board. So this meant the printed circuit board had to be designed over and over and over again. So we design a version of it, build it up, get it to work, test it, and use a spectrum analyzer and a modified probe, which is basically a standard spectrum analyzer probe and a paper clip that was connected to it to make a loop antenna, a very small loop antenna. And then that loop antenna was used, and you would just run this over the printed circuit board, and somebody would record on a grid of paper that represented the printed circuit board and keep track of what signals were where on the printed circuit board. And so after you got this map of where the signals were leaking from the printed circuit board, and you'd drawn this out on this gridded paper, then you would study that and the circuit board and use grounding techniques to readjust the layout of the printed circuit board to minimize those signals. Basically what you're doing is introducing capacitance selectively and by way of the PCB layout to absorb those signals so that they don't get out in the first place. We had a technician there, his name was Joe Cruz, who I hired. He was great now. I trained him in this technique. So between Steve Ray and this technician Joe Cruz and myself, we had a process by which we could engineer out those tin cans and reduce the cost of building these devices. And so that was one of the three things that I introduced to Atari: project management, use of this critical damping method, and the use of professional industrial designers to design the cases so that they look like. So we had the FCC certification was done by a company out on Flower Field, Long Island. So it was a short drive from New York City out to Flower Field. And, we got it passed, I think it was the second time around. First time we took it out there once, we went back, did another iteration of the critical damping design process, and on the second time, I believe it was the second time it passed. And then we had a design that was ready for production. Then it was a matter of getting the factory capacity out in the Middle East to ramp up production. Some of that capacity was in Taiwan, where Atari had a lot of factory capacity. And so I spent a lot of time in Taiwan finding additional capacity and learning to love the Taiwanese people. The Taiwanese, by the way, are great people. Taiwan, at least at that time, was a great place to be. They had a great lifestyle there, and they're not at all like Chinese people, and they don't belong to China, and they don't even seem like Chinese people. Just in case you ever wondered about this whole thing about China trying to take Taiwan over again and take it over and make it part of China. Mm-hmm. My experience there tells me that that's a bad thing, and that we should fight for the freedom of the Taiwanese and fight for them to maintain their independence on that little island that's off the coast of China. And that was my experience of being there. Also, there was the experience of the alleged Hong Kong manufacturer, which connected with the Chinese manufacturer. And of course, they have a lot more capacity than Taiwan ever could, because Taiwan is just an island.
Sure.
But Chinese are different people, and they have issues that are not compatible with us here. And we're seeing it every day, ever since then and now. It was a learning experience for me, because I had to learn all about how plastic gets manufactured, and the manufacturing processes, And back in the day when they were using the little tin cans as shields, and cheaply manufactured electronics still uses those cans today because it takes engineering talent and it costs money to apply the critical damping method. So in the low-end factories, even today, you'll see there'll be a copper wire cage to provide shielding, and some little lady quality assurance type person. They were often females back then. I don't know why, but they just tended to be females. I think it was attention to detail or something. They were just good at it. They would test the units coming off the production line to make sure that they had same basic specs with respect to RF radiation as the design called for. And they would sit inside those cages and test, and then they were allowed out. And then they have to go back into the cage. But it was there'd be like 2 or 3 or 4 of those units, cage units, for each factory location. And with the critical damping technique, that was not necessary and sped up the whole process considerably. And I think that the Chinese acquired that skill, and like everything else, they probably stole that technology and used it for themselves. I really don't know, but I would imagine that that's what they did, because they were very interested in perfecting their mass manufacturing capability. That was a very interesting part of the whole project, and it kept me away from home for long periods of time. I became very homesick while doing that. I also developed a love for the Asian people. I learned to speak a little bit of Mandarin, and I've always liked Chinese food. Yeah, even the Taiwanese beer was good, because if you got the time, you can buy Taiwanese beer here, but it does not resemble the beer that you got there. The beer in Taiwan had no preservatives and no additives. So I would go out drinking at night with the Atari guys from the factory crew and factory management people, and they would drink lots and lots and lots of beer, and you get no hangover in the morning because it contained no preservatives, no bad things that cause the hangover that you get. I remember when I first went there to this, I came in on the plane, settled myself into my room, then met with the other Atari guys that were traveling with me, and we went out to this cabaret in downtown Taipei, and there was a dancer there who came to our table and sat down because she spoke very fluent English. And so we're taking our turns talking to her, and so the guys were getting the idea of hitting on her and all that. Finally, I asked, her name was Susie Wong. I said, Susie, you speak perfect English. How did that come to be? And she said, oh, I have a degree in poli-sci from Rutgers. And I said, oh, yeah? Well, why are you working in this cabaret? And she said, well, I really didn't like the whole American culture, and I enjoy working in this cabaret more. And that gives you an idea of how at peace the Taiwanese people were with their lifestyle. I mean, they enjoyed their life the way it was. She had gone to America, gotten a college degree, and decided that that was not the life for her. And there are all kinds of less family-friendly stories that I could tell in Taiwan, in deference to the Taiwanese people, among others.
Just stay tuned to Antic After Dark for those stories. Anything else to say about the XL machines, or should we move on to what happened next?
Well, what happened next was that those machines went into production. Atari moved on, and I eventually moved on from there. And then I began my phase, because everybody told me that I should do it. You know, a lot of people that I knew were like, well, Steve Jobs is rich, and Steve Wozniak is rich, Bill Gates is rich. You should be rich too, and you should run your own company. And I actually took that seriously for a while. So I did start 2 companies. I started 2 internet service provider companies in New York, which needed them at the time, and discovered that I prefer to be an engineer rather than an entrepreneur.
Mm-hmm.
And I had several other opportunities to be a big-time entrepreneur and passed them up for one reason or another. During the dot-com boom, remember the dot-com boom of the 90s?
Sure, yeah.
And I was approached by Price Waterhouse because I was doing a lot of consulting work in New York City. And they approached me, and they wanted me to create an IPO mill, where the idea was that you come up with a technological idea, create a company around it, and then take it public. And all the financial guys in New York City get rich taking it public. And I thought about that for about 5 minutes and concluded that I didn't want it. And there are a couple of other opportunities. So my interest has always been in being an engineer and a technician. So when I left Atari...
So how did your time at Atari come to an end?
You know, I don't really remember. It was just that the whole R&D office in New York was kind of falling apart and losing its cohesion and its direction. And I had done these 2 products, and that had been its reason for existing. And when I completed these products, I think they just really didn't know what to do with that next.
Okay.
And not much was happening, so I left. I started one of the 2 companies that I started, and it was a very slow start, and I needed work. So I stopped starting up the company for a short period of time and went to work at CBS Toys. CBS had purchased, I don't know what, Fisher Price Play School, a bunch of toy companies, and thrown them together in this building built in the swamps of New Jersey. And the building was built on pilings that they had thought were going to last for 100 years, but actually there was a form of bacteria that lived in that Jersey swamp. It was just as tough as anybody from Jersey. Anybody from Jersey would know. And that bacteria ate the pilings. So they built a building on these pilings. Pilings got eaten up within a year or 2 instead of 100 years. And then the building started listing to starboard and filling up with marsh gas. And eventually it had to be evacuated. But during the time that the building was occupied, I worked on the Max Steel robot, which was the last significant product that I developed. And that was the swan song product of the vice president at CBS Labs. And it was a full-fledged robot. And you can Google this, by the way. There's plenty of information about it on the net. And every once in a while, one of them becomes available on eBay. And it was an amazing robot for its time. If you look at robots that are built today, most of them can only do the same kind of things that this robot can do. They might be a little fancier. The industrial design might be a little bit better. It might be better here and there, but actually not that much. The Max Steel robot had a 3-speed transmission, so that he could scuttle along the ground pretty fast. He had a single articulated claw, so that he could, his design feature was that he had to be able to pick up Dad's beer with his claw and bring it to him from the other side of the living room without spilling it on the carpet. And then Dad had to be able to grab it from the claw and then be able to drink it so that his son could operate the robot, and he could say, "My son is a genius because we bought him this robot and he makes the robot deliver the beers to me while I'm watching TV." And they had some crazy marketing scheme that was based on that concept. And then it was going to be, there was a Saturday morning cartoon show called the Max Steel Show. And it had the robot, there was a cartoon character in this. And it consorted with superheroes, deposed villains. And they made these cheap little, crappy little models of Max Steel that didn't do anything. It cost $9, and the markup on it was like 1,000%. And the idea was to sell these crappy little models. So he wanted the rich kid, the leader family in the neighborhood was to buy the actual Max Steel robot, which sold for a whopping $300 or $400. And they would have that, and all the other people in the neighborhood would feel inferior to this family and go out and buy the cheap little replicas for their kids so that their kids wouldn't feel disadvantaged. This was the kind of crass marketing thing that was going on. It was absolutely horrible. The marketing concept behind it, it was despicable. But building the robot was pretty cool because it was designed to be a loss leader. So it cost me $300 to build the thing. And we only made a few thousand units. And they were built in the same factory in Lyndhurst, New Jersey, that built the Hindenburg blimp, or dirigible, whatever. The one that blew up famously. So it was built in the same factory. And it had 5 microprocessors, small ones to control the motors and things. And then it had a main one. My job was to design the main one that was 6502 based, but it was a custom chip and it had a lot of extra onboard circuitry so they could do a little bit of voice recognition and speech synthesis. It had full speech synthesis and a remote control so you could drive the thing around, a macro programming language so you could program it to a certain extent. It had a real-time clock so that you could trigger it to do certain actions at certain times. And it had lights that flashed when it spoke. And they did some publicity stunts with the Max Steel robot that were pretty cool. They sent him down to Washington and had him sidle up to senators and congressmen and shake their hands with his articulated claw and say, "Hello, I'm the Max Steel robot," and make sure to get film of that and get that on the evening news, help sell more Max Steels. And but it was a very weird project to work on. And the other chips that were in him were done by guys at CBS Labs in Stamford, Connecticut. So I spent a lot of time working with those guys. When the prototypes were being built in Secaucus, New Jersey, which is where the sinking building is located, there were a couple scenes there that were like I felt like I was in a science fiction movie. We had 4 of these things laying belly down with their backs open and technicians fiddling with the wiring harnesses beside them. And I would be there for moral support and to answer engineering questions that they might have while they were trying to bring these things up. And there was a Moog synthesizer there that they used to create sounds for various toys that they built. And I'm a musician, so I'm playing music to entertain the technicians while they work on the Moog synthesizer and getting some really spacey science fiction kind of sounding stuff going. And
of course.
It was getting to be very surreal. And one night, one of the technicians slipped with one of the connections on the harness and completed an unexpected circuit. And the Max Steel started lighting up and saying, "Help me, help me, help me, help me, help me." And that was just too weird. I really felt like I was in a sci-fi movie for a few moments there. He couldn't wave his arms around like the one in Lost in Space, but he could yell, "Help me, help me, help me." The other funny thing about that was we would test them out by taking them to the executive offices in the city and driving them around there so the executives would see the Max Steel robot whizzing around up and down the corridors. And he had some secret vocabulary that could be unlocked using a combination on the keypad. This is an Easter egg. If you ever buy one of these things on eBay, I don't remember what it was, but there was an Easter egg combination on remote controller that unlocked the extra vocabulary. And so we would program him to dart into an office, raise his claw, rotate it, open it, and say, "Go F yourself."
Wow.
So his arm back, turn around and retreat. And the executives were highly entertained by that. But our boss, the guy who was running the project, did not know about this. And when the product was introduced at the toy fair, this was his big moment before retiring. He got up to the lectern and was addressing this room full of toy buyers at the toy fair, which happens every year in New York City, and that's where buyers decide what toys they're going to buy and put in stores for the year.
Uh-huh.
So it was a very important day for this guy. It was his goodbye to the toy industry. And he's up there behind the lectern introducing Max Steel. And then he gave the cue for Max Steel to come over and introduce himself. And something went horribly wrong. And he wheeled around and rotated his claw and gave the finger to this vice president and told him to go F himself. And it looked like he turned purple, and it looked like he was going to have a heart attack. It was total pandemonium in the room as all the buyers rushed up to be the first to order a Max Steel. And they sold out in the first 5, 10, 15 minutes. It was an amazing moment to see. The power
Wow.
of cursing like a sailor when you're a robot, I guess.
Huh. Oh, that's crazy.
Yeah, and after that, I had to learn to work for financial institutions because all the non-financial businesses were fleeing New York City at that point. So I worked in the finance industry after that for about 10 or 20 years doing network engineering and introducing banks and financial firms to the concept of network security. 9/11 came along. And the day of 9/11, I was working in the Lehman Brothers building at Fuller World Financial Center, right across from the South Room. That day, 9/11 was a Tuesday, if I'm not mistaken. My alarm clock went off. And I woke up and I don't think I'm going to go to work today. Turned off the alarm clock, went back to sleep. My wife got up, went downstairs where the television was, made some coffee and breakfast, and then came running up and saying, "You've got to see this," and just dragged me down the stairs half awake. I sat down in front of the television set, and there was the live coverage of the plane that had crashed into the North Tower first. And I'm looking at that, and I started crying because I knew my life as I knew it was over, and it was. That was the end of my existence in New York City as an engineer. So I still do systems integration and network engineering, and these days I do DevOps and help companies transition to the DevOps model. Do what I can that's innovative. I got a patent back in 1976. I got a patent for level 3 communications, which is sort of like the nation's backbone internet provider. I got a patent with them back in 2013. I've been using AI techniques in various things. I have some pet projects of my own. I have an internet radio station that I DJ on periodically as a pseudonym. I have had periods of time, including post 9/11, when there was no work in New York City, to other periods of time when I haven't found work, and I've worked as a musician. I play the saxophone. I play acid jazz. The easiest way to describe that is if you think of a lot of the music that Miles Davis played on the trumpet, well, I play music like that on the saxophone. I live in the Boulder, Denver area now. I've had 2 bands, which will remain nameless for the purposes of this discussion, in Boulder. I'll probably have more bands in Boulder. Boulder is a great place to have a band because you've got the University of Colorado there, or Colorado University, excuse me, CU, is located in Boulder. So there's a huge college population there of kids that really love music, and they love avant-garde music, and they're a great audience, and I love to play for them. And so I'm planning to do some more acid jazz performances there as time allows, and continue to do engineering for as long as I can. Eventually, I think I'll have to fall back to business consulting and other things, but I can't imagine retiring. So between doing doing consulting and being a musician, living in this area near the mountains, which I've come to really love, hopefully I'll keep doing that for a while as I continue to become an old fart. And as I mentioned to you previously, I got out here because of the Max Steel robot. The chip that I developed for the Max Steel robot was fabbed in Fort Collins, Colorado, by NCR Microelectronics. And it was the first product or chip that they had designed and fabbed at that facility. So we got a special deal for doing it there. And back in the day, I spent a couple months out here in Colorado, drove around in the mountains, explored my way around while I was hanging out and doing that chip, and decided that one day I would move out here. And it turned out that 9/11 was the thing that made me do it. Because people that don't live in New York don't realize that when 9/11 happened, 250,000 people instantly lost their jobs. And the people that didn't lose their jobs were not going to give them up for anything. So that meant that there was this huge unemployment problem. And it was really difficult to find work. And so I was playing in a couple different bands in the New York City area between 9/11 and the time that I moved to Colorado. And I was playing with a reggae band at the Leopard Lounge, which is a well-known venue in Manhattan, where people smoke the ganja and listen to reggae. And so my band was playing the Leopard Lounge on a regular basis, and we got a gig in Philadelphia. So we drove up to Philadelphia to do this gig one day, and got up there early so we could all have Philly cheesesteaks and enjoy the weather. It was springtime. And we're sitting in a park near the venue where we were going to play. And we were just watching the people there, and we were like, oh, these people are normal. And the light bulb went on. The people back in New York were not normal. They were traumatized by 9/11. And that was when I got the idea that it was time to go. So that was my impetus for moving out here to Colorado. So I did.
Wow.
And I had been planning to do it anyway, so I'm pretty happy living in this area. And there's a lot of tech in the Boulder-Denver corridor. And it's just growing like wildfire. There's a lot of startups here. The cable companies all do a lot of their R&D and software development, platform development is done in the Denver area. And there's just a lot of high tech. The Cable Labs, the R&D arm of the cable industry, is located halfway between Boulder and Denver. Level 3, the nation's fiber backbone for the internet, is headquartered in Bloomfield, which is halfway between Boulder and Denver. So there's just a lot of high tech activity going on here. So it's an exciting place to be, and an exciting place to work, and be dealing with technology.
Awesome.
That's where I am and what I'm doing now.
Excellent. If you could send a message to the Atari fans who are still using their 600 XLs and things and listening to this podcast, if you could send them a message, and you can right now, what would you tell them?
I would say that the 6502 was a really awesome microprocessor, and it deserved the role that it played in the early years of home and personal computing, much more so than the Intel chips. The architecture of the 6502 is great, as any programmer knows. And a side story that at Atari, one of the things that I did after, you asked what I did after the XL computers and the VAL system. There was one thing that I did, and I collaborated with Gary Summers, who was a CPU architect that Atari hired. And he and I collaborated with other people to develop a next generation 6502, which was called the 65816.
Mm-hmm.
And what we did was we incorporated the best characteristics of the 6809 processor by Motorola, which was architecturally related to the 6502, but more advanced, and solved some of the problems with 6502. And we also took the best features of the Motorola 68000, which was the Motorola 16/32-bit architecture. And we combined those architectures with the 6502 to come up with a microprocessor that was advanced in those respects, but backwards compatible with the 6502 and could run 6502 code. And Atari decided that it did not want this processor that Gary Summers and I, Gregg Squires, cooked up. So the rights to it were sold back to Chuck Peddle. Chuck Peddle is the guy who created the 6502 with a bunch of Texas housewives on laying it out on card tables in some warehouse or something. And that was how they created the 6502. And he bought the rights to it and his company manufactured the 6502 in two formats, or the 65816, in two forms that it was designed. It was designed as a plug-compatible replacement for the 6502, so that you could actually take this chip and plug it into an Atari 800 or 400 or any of these computers that we're talking about, the Commodore 64, the Apple II, they're all based on the 6502. You could plug this chip in, and it would run all the software invisibly as if it was a 6502. But you could write software for it, trigger it to switch into the other mode, and then use all those advanced features before triggering it back to the 6502 mode so that it could fall back to the other software. And it was used in the Apple II GS. The Apple II GS actually used that chip and was manufactured with. And Gary Summers and I have always laughingly speculated as to whether it was called the Apple II GS because there were two guys with the initial GS who designed the microprocessor, Gary Summers and Gregg Squires. But we're pretty sure that that's not the reason.
All right. Officially, it was graphics and sound, but I like your answer too.
So there you go. I never really asked Wozniak, who I was still in speaking terms with, not Steve Jobs, and asked him. I never asked him that question. I'm sure he could have answered. And I guess graphics and sound, that was probably in the sales literature, right? Figured it out.
Yeah.
But anyway, it was a nice joke. But so my message to Atarians is that this is great technology, even by today's standards, and learning how to program it is a really great exercise because computer science graduates graduate and they don't even know how to program these devices. And it's a great skill to have because then you understand how the computer actually works. A lot of people working in computer science today don't know how this stuff really works. And it's kind of a problem. Others would argue, who needs to know? But
right.
I always think it's an equalizer. I always thought of these computers as great equalizers. And we're so dependent on this technology. I think it's important for large numbers of people to understand the technology so that it doesn't get away from us and start to control us. Because look at the problems that we're having today with Facebook and other companies. We have computer privacy issues. We have surveillance issues where we're all targets of surveillance for marketing purposes. A lot of these things that are changing society in bad ways, that are making the quality of our lives worse. One of the ways to get a handle on those things and rein them in is by having more people that understand the technology. And certainly our congressmen and senators today have no clue how this stuff works. And it's to our detriment that they don't. So and that using these products is a great way to have a fundamental understanding of the technology that you can't get any other way. So kudos to anybody today who's still using these computers and is still writing programs for them, because they have a deep understanding of the technology you can't get any other way.
Good answer. Thank you. Thank you for making the XL machines, for your part in them, because they are wonderful.
And I hope that people will read this document and get some insight into how products are born and how they're mass produced. Because as I mentioned to you earlier, there's a lot of people that labor away all day long, build products, blood, sweat, and tears. Their products never see the light of day. I was just very fortunate to have a lot of products that I've mentioned in our conversation that did see the light of day. And I feel really blessed for that, because I know how many people have the opposite experience. It must be very frustrating and terrible. But there is a certain science to the mass production of consumer devices. And it's the same as understanding the computer technology itself. If you understand the processes behind all of these gadgets that our lives depend on, and having some understanding of the processes by which they're designed and go into production, you can better be able to command them and not have them command you.
If you enjoy these interviews and would like to contribute, make a tax-deductible contribution to the Internet Archive, a nonprofit digital library that has done incredible things to preserve computer history. Make your tax-deductible contribution at archive.org/donate. Thanks.